So, hello everyone. Hello, bacho. How are you? I hope you all are fine. Hi, hello everyone. This is your Vignesh. This is my channel, Mr. Vignesh Tutorials. Today we are going to discuss about our M1 Max Engineering. I think it's our class 4, I guess. Today we'll go with our Unit 1 matrices. In that, we'll go with a topic called as. We'll go with M1. And it's our 8th. I think it's some class 4. I hope. We'll go with our eigen values and eigenvector. The topic name is eigen values and eigenvector. Okay, it's a very important topic. It will be useful for your whole engineering as well. Okay, please concentrate here. So, for any matrix A and a non-zero vector X, if there exists a scalar lambda such that A into X is equal to lambda times of X. If you are multiplying this matrix A with that vector, non-zero vector, and the scalar is also multiplied with that non-zero vector, if those two are equal, then you call this as homogeneous equation of having n number of solutions, n number of non-zero solutions. You get this n number of non-zero solutions. Here I'll bring both this side 0. X I'll take common, A minus lambda times of I. This is a matrix, so here nothing is there. So we will take a unit matrix. The unit matrix is also of same order with respect to A is equal to 0. So whatever is there, if A minus lambda I is equal to 0, this is the, we have to find the determinant of this, is called as, A minus lambda is called as characteristic equation. What is your characteristic equation for a matrix? Given means to find that x vector unknown number of solutions. Like if the matrix is A, x vector also will have 3 number of solutions, and this lambda you have to find lambda. The lambda values are called as eigenvalues, and obtained vector is eigenvector. So this is a characteristic equation for getting your eigenvalues and eigenvector. So nothing, students, it's very easy. There is a lambda called, it's a scalar, okay, scalar called lambda. There exists a matrix A, okay, and some x is a non-zero vector it is. If your multiplication of A and x and lambda and x both are equal, then that is a homogeneous solution with n number of non-zero solutions. And if those two are equal, you are getting this kind of equation where non-zero vector cannot be equal to 0 and this determinant can be equal to 0, right? So if that is equal to 0, then that is called as characteristic equation of this eigenvalues or eigenvector, and lambda values whatever you get is eigenvalues, and the vector obtained there for the solution is called as eigenvector. Okay, any kind of doubts, please mention in the comment box and take a screenshot of it. It's very important. Let's solve some example. Our first example is a matrix A, or you can tell it's a problem. Let's take a question 1, 2, 2, 0, 2, 5, 0, 0, 0, 3. Let's take this an example 3 into 3 matrix. It's a matrix A. We have a known value x1, x2, and x3. So matrix 3 by 1. You have to find this one. You have to find the lambda. Okay. How to solve this? Now let's see here. For this matrix, I am going to write characteristic equation A minus lambda I is equals to 0. Let's tell that A is 2, 2, 0, 2, 5, 0, and 0, 0, 3, minus lambda times of I is lambda, 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 and 0, 0, 0, 0, 0, 0. Okay, lambda into unit matrix, right? Okay, so now here you will get like 2 minus lambda 2, 0, and 2, 5 minus lambda 0, 0, 0, and 3 minus lambda you get. And you want determinant value is you know this determinant value should be equal to 0. So to get that, so here only this third column I will do because other two are zeros, right? So 3 minus lambda I am taking as it is, and I will multiply these two. 2 minus lambda into 5 minus lambda minus 2 to the 4 is equal to 0 LB. So 1 is this solution, lambda is equal to 3. Now I will take only this solution. 2 into 5 is 10 plus lambda square minus 5 lambda minus 2 lambda minus 7 lambda minus 4. So lambda square minus 7 lambda plus 6 is equal to 0 is equal to 0. So I can write this one as lambda minus 1 into lambda minus 6 I can write. So I'll get this same value, yes, is equal to 0. So lambda equal to 1 and lambda equal to 6. So you got lambda is equal to 3, 1 and 6. So lambda values 1, 3, 6 are your eigenvalues. I hope you got it. See here, once again I am explaining. This is your matrix 2, 2, 0, 2, 5, 0, 0, 0, 3. This is your vector x1, x2, x3 non-zero solutions, and you have a minus delta I, that is nothing but, sorry, a minus lambda I, that is nothing but 2, and this lambda is, you know this one, lambda, 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 because all one ones will be there, no? Lambda times means it will become this one. So this I am making determinant with this one into multiplication, because these two are zeros, it is easy for me, and this is anyhow product is 0, right? So this becomes lambda equal to 3, and these two I am making into factorization, so lambda equal to 1 and 6. These are my eigenvalues. So you are clear as far as this solution. Please note it down. I am going to erase it. Okay. Now we got these solutions. Now let us substitute in this equation a minus lambda I. It is 1, 3 and 6, right? You got lambda values 1, 3 and 6. Now a minus lambda I, okay, implies 2 minus, if lambda is equal to 1, for lambda is equal to 1 I am telling, 2 minus 1, and here 5 minus 1 and 3 minus 1, remaining are same as you know. So that becomes 1, 4, 2 and 2, 0, 0, 2, 0. Becomes this one, a minus lambda I. Into x is 0, right? You have to get this one right. Into or x1, x2, x3, you have to get zeros. This is 3 by 3 matrix, this is 3 into 1 matrix, and you will get again 3 by 1 matrix. Okay. So let me expand this one. Now here I will get the equation as x1 plus 2x2 is equal to 0. Let it be by equation 1, and 2x1, if I can divide, I'll take as it is 2x1 plus 4x2 is equals to 0. Here I'll take 2 common, means x1 plus 2x2 is equal to 0. I'll get the same equations as above. For third one, if I take 2 times of x2, I missed some value, right? 0. Okay. 2 times of x3 is equal to 0. So here directly I am getting x3 as my 0, and I want x1 and x2 values. Okay. If I substitute 1, I am getting such kind of equations. I got my x3 is 0 directly. I have to find only my x1 and x2. So it has a number of solutions, I said no. Here if x1 equal to k, then you can have x2 is equal to minus k by 2. Or x2 is equal to k, then x1 equal to minus 2k. As k value changes, your x1 and x2 value changes, and x3 is 0. So you have a lot of solutions when eigenvalue is 1. Okay, please take a screenshot of it. Okay, Now I'll take lambda value 3. My eigenvalue I'll take it as 3 now. Let's see what happens. A minus, I'll write remaining numbers as it is first. Only these 3 I'll change. 2 minus 3 times of 1, that is minus 1. 5 minus 3 times of 1, that is 2. 3 minus 3 times of 1 is 0. So I am getting this kind of equation into my x, x1, x2, x3 is equal to 0 to obtain solution. So I write the equations minus x1 plus 2x2 is equals to 0 and 2x1 plus 2x2 is equals to 0. This be equation 1, this be equation 2. I'm simplifying it, I have taken 2 common, and third one anyhow it's 0. So here also we get 2 equations. Upon adding both the equations, add 1 plus 2 implies 3x2 is equal to 0. That means x2 is equal to 0. So x1 also equal to 0 and x3 is some constant. It can be any value. So here the solutions are these 3. It can be any value and x1, x2 is equal to 0. Okay, note it down. And next I'll take lambda value 6. I'll take lambda value as 6. Now 2 minus 6 is minus 4, 5 minus 6 is minus 1, 3 minus 6 is minus 3. So I got this. Now what to do? Same, minus 4x1 plus 2x2 is equals to 0, equation 1. So I'll take common. Minus 2x1 plus x2 is equal to 0, equation 1. And minus x2 equal to 0, this is equation 2. And finally minus 3x3 is equal to 0, this is equation 3. So x3 equal to 0 and x2 equal to 0. If you put substitute in this, you will get x1 equal to 0. So 0, 0, 0 are solutions for this one. For the first one, for lambda equal to 1, the solutions are x3 is 0, this is k means this is minus 2k, or vice versa, or this is k means this is minus 2k. And for the third one, you got this is k, these are zeros. You got such solutions. These are your eigenvectors for the eigenvalues of 1, 3 and 6. So I hope you understood it very clearly. It's a very classic level of problem. With one such example, I understood like it's very simple, and I hope you all also understand it in the same way. If you want, I can help you with further more problems, but I hope this is fine. If any kind of doubt is there, please mention in the comment box. I will love to solve those. Okay. And by this class, eigenvalues and eigenvectors you will be sure enough to solve with the problems. And in next coming sections, we'll deal with further more topics in the matrices chapter. Okay. Until then, this is your Vignesh from Vignesh Tutorials signing off.